Good morning, good afternoon, good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Voorhees, your host. I'm the editorial director with Data Science Central and also chief data scientist for Data Magnum. So I'd like to start off our event today by thanking MemSQL for sponsoring today's event. MemSQL is a longtime supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. Now, past webinars are available on demand at datasciencecentral.com, and if you haven't had the opportunity to view them, I encourage you to take a look. They provide very useful insight into a wide variety of topics of interest to our data science community. Now, today's webinar is entitled Data Lake Advances in the Age of Operational Machine Learning and AI, and that'll be presented by MemSQL. Now, before we start, I'd like to briefly review the format of today's webinar. Today's event will be an hour long. We'll have one presenter, who I'll introduce in just a minute. There'll be 10 to 15 minutes of Q&A following the presentation, and this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. Now, I'd also like to encourage our attendees to provide questions throughout the presentation, so we'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. Well, I'm very pleased to introduce today's speaker, Rick Negrin with MemSQL. Rick is the Director of Product Management at MemSQL. He's been working in technology industry for over 20 years and started his career as a software engineer working in a couple of startups. That was followed by 12 years as a product manager at Microsoft on the SQL Server team, working on the core SQL Server engine, as well as the Azure SQL database. So Rick, hey, thank you for being with us today. We're looking forward to your presentation. Now, the popularity of data lakes has given data scientists and organizations the needed foundation to discover breakthrough insights. But many implementations are falling short of the performance, manageability, and integration needed for a successful, broadly adopted data-driven operation. So in today's Data Science Central webinar, we'll explore some innovative new architectures for data lakes that accelerate time to insight, reduce operational complexity, and effectively integrate with operational systems to help you deliver greater impact within your business. You'll learn the new reference architectures for data science that can boost performance and reduce costs, how to reduce complexity commonly caused by data lake acceleration tools, and techniques for bridging the gap between data science and operational systems. So Rick, with that, I'm going to turn it over to you. You can begin just as soon as you're ready to go.
Thank you, Bill. I really very much appreciate the opportunity to present to your community today. So let's get started. So as Bill mentioned, I'm the product manager, the director of product management at MemSQL. Today I'm going to cover data lake advances in the age of operational machine learning and AI. So prior to the advent of data lakes, data lived in silos. And it became clear that by leveraging these various data sets together, companies could get valuable insights into their business to either increase productivity, increase sales, identify new opportunities. And however, using those various data sets was extremely complicated and costly. Data had to be transferred to a central location, usually in the form of some form of enterprise data warehouse. Often took months of planning and typically had a very rigid structure. It was brittle, and by the time it was set up, often the requirements had changed, making it difficult to get to the data you need at the time you need it. So organizations were searching for a way to get data to one spot where it could be organized, cleaned, and joined with other data sets in a timely fashion. And their realization was that if they did this, there would really be no end to the various ways data could be used. Probably the primary reason people were doing this was really to understand their customers better, understand what they wanted out of their product or services, and then use that information to improve the products or services to give a better experience for the customer and drive more business. But there's also other ways, other things that people are looking to do around improving internal management of the existing data, creating new revenue streams. Really a myriad of different ways that people are trying to do these things. But they were stuck because the technology was making it too difficult to do. And so big data came along, and big data is really the umbrella terminology for the various NoSQL data stores, Hadoop being the primary one, that came along trying to answer the scale and management problems that presented that were presented for the legacy technologies. And it's been pretty clear that this is a widespread problem across all the verticals and industries, because you see the adoption of big data really across all companies, big and small, and all the different verticals. And you can see in the last 10 years, we've approached tens of billions of dollars with the intent to continue spending another order of magnitude up to $100 billion. So clearly the problem is still there, it's still acute, and people are still trying to solve it. So this presentation, though, isn't just about me talking to you. I also want to hear from you folks. So if you can use the poll, we'd love to hear from you. What is your most current pressing limitation with your data lake? I'll just give everyone a moment to choose their responses, and then on the next slide. And so you can see, okay, so some people don't have a data lake. And one of the primary issues is it's hard to integrate with other technologies. Or the complexity of use. Yep, and that pretty much aligns with the experience that we're seeing in the field, is that people are seeing that there's too many options and they don't know how to use it, and that the technologies they do find are very difficult to connect in to make it viable and easy technology to use. Primarily because the relational database technology has been around so long, and customers have built up a tool set with a familiarity of existing tools. And so when you introduce a brand new tool set, like big data, NoSQL, learning that it's got a steep learning curve and having to abandon all the existing tools is very difficult. All right, so let's move on. So while the big data tools so far have solved a lot of the problems, they've solved ability to collect everything and get it into a centralized place at scalable, low-cost storage reasonably fast. They allowed flexible schemas, which made it easier to bring the data in without having to go through the rigid analysis and ability to set what structure it needed to be, and then the ability to have it centralized in one store. But issues remain. The operational reliability and performance is difficult to maintain. It's hard to deliver it against your business SLAs when you have requirements on how fast the data has to come in and how fast the data has to come out. Really, what I call the time to insight. From the time data is born to the time that you're able to get insight against it. Often businesses have requirements on what that time needs to be, and it's challenging to make it work with the existing technologies. And one of the bigger problems, and we saw that in the polling from the previous slide, is interoperability with existing enterprise tooling. One of the hardest things to do when it comes to software isn't the technology so much as training people on new technology. So if you can enable people to use the existing technology that they know how to use, existing patterns, you can get much better adoption. And lastly, around data governance. One of the consequences of using a data lake, when you dump a bunch of data in and it's all in different forms, it's hard to know what you've got in it and maintain your compliance and certifications. So let's drill into it a little further. So on the pros, you have high-speed ingest and handling large volumes of data, kind of looking at it over the life cycle of data as it moves through the system. With technologies like Spark, you can transform the data before it lands in the storage. Spark, for those who don't know, is a compute layer, distributed compute layer that lets you write Java programs to go and process the data, often used for transformations and sometimes cleansing or machine learning. The storage is scalable storage, and lower cost to handle the very large growth in data that we've been seeing. And the last is there's SQL-like tools that let you go explore the data. Things like Hive and other tools of the like that have a SQL-like syntax, but don't support the full SQL that you'd be familiar with if you used a relational database. So if you, the next question we want to ask is, what type of project is your data lake expected to help with? Now, for those who don't have a data lake, if you were to build a data lake, you can sort of use it as if you were to have a data lake, what would you expect it to help with? And there's a number of choices here. Now we'll wait a moment while people select their answers. Right. So not surprisingly, I see most people picking the generalized data science projects. But interesting to see the personalization recommendation as a common pattern. Customer churn, as I would expect to be a somewhat common pattern. Excellent. So the key takeaway here is that there's probably a variety of different projects that people want to do, but almost everybody has some project in mind that they would like to do. So it's clear that the data lake is an interesting project and that people want to make use of it. Now, the challenges that people have as data moves through the lifecycle of the current architecture is it doesn't have transaction support, and so you have to worry about duplicates and data not being clean in the system. The transformations have to occur outside the system, which limits the ability to do high-performing ELT and to get lineage visibility as to where the data came from and what happened to it. When you dump everything into a data store, and especially with schema lists, that makes things more complicated when it comes to governance and regulatory requirements. And probably the most challenging and most visible piece is poor query performance. That while Hadoop and the big data NoSQL stores are often good at batch processing, so doing a job that crunches the data and gives you an answer tomorrow, which for some class of questions is okay, it's not as good for the interactive where I want to explore the data, run a query, get some data back, and then based on that, do another query. That if you're taking minutes or hours to run queries, it really slows you down and makes it difficult to make rapid progress in finding that insight that's going to transform your business. And it's very clear that this problem hasn't gone away. And in fact, if anything, it's more acute. According to this Harvard Business Review study, data-driven decisions were companies that were data-driven were on average 5% more productive and 6% more profitable. Very much that's just the average, and you can see the companies that are very successful and the outliers are probably much more productive and profitable than that, probably in the 100%. So there's a huge advantage if you can figure out how to do it right. So we kind of talked about what the challenges are with data lakes. So the question is then, how can we improve them? How can we overcome these problems, these challenges? And that's where NewSQL comes in. And you can think of NewSQL as the best of both worlds. That's why, hence the name New and SQL, both talking to the old relational technology as well as the NoSQL movement. And the idea was, what if we could have just a system that solves the problems that the NoSQL and the big data technologies were trying to solve around scalability, reliability, ingest performance, and get all the goodness of modern architecture, modern distributed scale-out architecture, but still maintain the relational and the scalable query optimizer technologies that you're familiar with existing legacy database technologies. What if you could have your cake and eat it too? Have the best of both worlds. And that's what NewSQL is all about. And there's a number of NewSQL technologies that have come out on the market in recent years who've been attempted to solve this problem. And Gartner agrees. According to Gartner, by 2020, they think almost a third of data lakes will all be built on some sort of standard relational database technology. And that those things will be equal to or even lower cost than what you get with Hadoop today. So the trend is shifting, and it's shifting for a reason. Because when you put, and it doesn't mean necessarily that the data lake will be replaced, but rather augmented or accelerated by NewSQL will be a common pattern. And the advantages are the NewSQL and data lakes both have a scaled architecture, so they both take advantage of parallel processing. You can use the advantage of tiered R storage. The NewSQL systems often leverage memory as well as SSD and disk, whereas the Hadoop technology typically is just disk, and so having them together allows you to get the advantages of faster storage with the trade-off of TCO. They both support high-speed ingest, so whether you're doing very large batches that have been SLA'd where they have to get in by a certain time, or you want streaming because the latency is important from the time the data is born to the time you see it is critical. Being able to satisfy both of those requirements is possible by using a combination of data lake and NewSQL. They both support flexible data formats, so JSON, full text search, spatial formats, as well as structured relational data. You need to be able to handle all these different data types in a modern system. And probably most importantly, as a scalable ANSI SQL, being able to use the familiar SQL language, the full set of the language, but in a scalable way. And that's why we built memSQL, the no limits database. It was about building a system that could behave and look familiar to those who understand relational technology, to people familiar with using a database, but break through the limits on scalability and performance and data types and distribution that people were stuck with the legacy architectures, to really get the best of both worlds of the modern scale-out distributed systems and the familiarity and of a standard SQL database. And so memSQL supports very high performance of ingest. I'd say we're by far the best in the industry at this. We regularly will do millions of rows per second ingest, or even tens of millions of rows in some cases. We support both structured and unstructured data. You can create a table and build your schema. You can also create a column that's of type JSON and store data that's just JSON directly. And so you can do a mix of both. We support transactions and analytics. So whatever workload you're trying to solve, it can be done in memSQL. And we have extreme performance and scale out with a sophisticated query optimizer that lets you get very fast performance and do it on a scale out distributed system. We support both cloud and on-premise. About half our customers run in a combination of AWS and Azure. The other half runs on-premise. So regardless of where you want to deploy and what's best for your business, memSQL works for you. And we do it all with a cost-effective performance. We run on commodity hardware, running any modern version of Linux. So scaling your cluster, you can scale it linear by adding more hardware as needed. So let's drill in a little bit on what the architecture would look like. So what we see is a traditional data lake architecture. You have your data sources on the left, whether it's streaming data or batch files or operational data coming from operational systems, coming in different forms of either batch or real-time loading. The data then comes into to the data lake, stored in typically HDFS, and then you have a number of computation layers, Spark, Hive, HBase, Drill, what have you, on top. Now, in some cases, you can use those layers directly, sometimes to try to do interactive stuff, although that's pretty painful, often to do MapReduce type jobs, to answer questions that don't need to be answered very quickly. But typically what ends up happening is you then have to, that the architecture gets used mostly to do organization and cleansing of the data, and then you end up extracting it, transforming it, and having to put it back into a data warehouse or a data mart of some sort in order to make it accessible to reports and sometimes even the applications of the data scientists. But if you were to replace that layer with memSQL, things get a little bit different. So one is you can accelerate queries because now your queries can go directly against memSQL. You can do your transformations into memSQL using a feature we call pipelines, which I'll talk about more in a little bit. It lets you eliminate a lot of the query tools that people were trying to use that were not working very well. And you can move the data from HDFS into memSQL trivially with a feature that's built in memSQL and basically automatically synchronize all or a subset of the data as needed. And this lets you eliminate a lot of the different data silos that you had to create on the side in order to accelerate the ability to pull the data out. So really simplifying the architecture overall and reducing costs. So there's a couple different ways, though, you can use it. So option one is you actually put all the data into MemSQL, you do all your transformations there, and then you push it to HDFS, mostly for archiving or for using HDFS for batch jobs. Another way is to do a Lambda architecture, where you actually push the data into MemSQL and HDFS at the same time, and keeping a subset of data in MemSQL for queries, and then flush it out the data as it ages out, and keep the rest of the entire set of data in Hadoop for long-term storage. The advantage of this one is that you have very little latency to get the data to MemSQL, but it goes naturally into HDFS. The trade-off here is then if you're doing any sort of complex transformations, you have to do them in two places, and that can be challenging. Third option is you land everything in HDFS and then pull it up into MemSQL as needed. And again, using the pipelines feature of MemSQL, this is pretty easy and simple to do without any third-party technology. The challenge with this one is that if you're very time sensitive on latency, then going through Hadoop and hitting disk and then going to MemSQL is going to slow you down. And so when time sensitivity is important, you want to go directly from, say, like a Kafka queue directly into MemSQL, like with a Lambda pattern with options 1 or 2. But if the latency isn't important, then landing in HDFS, doing your organization and cleansing there first, and then surfacing the data up to MemSQL to be your query layer, your system of access, makes a lot of sense. And of course, there's always the fourth option, which we like, which is you could replace your Hadoop cluster altogether with MemSQL. And for smaller Hadoop clusters, this can make some sense. But a more common pattern will be MemSQL working collaboratively together with your HDFS system. So let's drill a little bit in now into how MemSQL works. So MemSQL is what we call a converged architecture. So as I mentioned earlier, it supports transactions and analytics. It does that by having two different storage mechanisms. It has a row store that's optimized for memory and gives you very low latency, which is great for transactions, but also good for analytics as well. We also have a column store, which is great for large-scale analytics, doing group bys and aggregates, and doing scale over much larger sets of data, because you get a lower TCO because it's backed by disk rather than by memory. And what we find is most customers actually use a combination of row store and column store to get the right mix of performance and TCO that works for them, depending on exactly the query shapes and the requirements of what the problems they're trying to solve. And that's coupled with the ability to do high-speed ingest, to be able to bulk load or stream the data in directly into MemSQL. In terms of how we fit into the larger ecosystem, you can think of MemSQL the same way you think about a relational database, like MySQL or Postgres or SQL Server or Oracle. There's data sources that feed data in, and we can pull data easily from other relational systems or other NoSQL systems or object stores like S3 or Azure Blob, as well as messaging technologies like Kafka. We have very good integration, native integration with Kafka. We have a dedicated Spark connector that we built and that we ship, allow you to do high-speed ingestion and push of data to and from Spark. On the other side, getting data out, about half our customers build custom applications, and the other half tend to build dashboards using technologies like Tableau, Looker, and MicroStrategy. And one of the key strategic decisions MemSQL made early on was to invest in making the wire protocol for MemSQL identical to MySQL. So it's wire protocol compatible with MySQL. And what that means is that any technology that has a MySQL connector works natively and naturally with MemSQL. And so out of the gate, even though we're a new database technology that was proprietary and built from scratch, we have this giant ecosystem of tools that already work with MemSQL. And as I mentioned, we work both on-prem and the cloud. We have customers using us in a variety of ways, whether it's on bare metal or virtual machines. And one of the secret sauce pieces of MemSQL is our distributed query optimizer. That when you send your query into MemSQL, you send it in as if you're sending it into a single box database. And under the covers, it takes care of sharding the data and distributing your query across all the nodes, allowing you to get the full power of parallel computing with the ease of use of a single instance image. And we support full scalable ANSI SQL. So pretty much every ANSI SQL function that you might want, we support. We also have full ACID capabilities. So you can create a transaction, do operations, and be sure that all the operations committed or rolled back. As I mentioned before, we have support for a variety of different data types. You can create a column of type JSON or one of spatial or a full text search. A full text search allows you to create a Lucene-like query, a full text query, and embed it within your structured query. So you can do a mix of structured filtering as well as full text easily within your SQL statement. We have some pretty innovative algorithms for how we do query, things like fast query vectorization and compilation. These technologies is what allowed us to achieve our trillion rows a second scanned benchmark. You can check it out at memsql.com/trillion. Really blowing the doors off performance in a way that is the top of the industry. And we support extensibility, supporting things like store procedures and UDFs and UDAs, allowing you to put your business logic directly in the database to move it as close to the data as possible, which gives you a significant performance boost. To get data in the system, there's a couple of different mechanisms. There's obviously the simple way of doing an insert statement or even a batch insert statements. But we also support, for one-time loads, we support a technology called, or a pattern called load data, which is a bulk loading API. If you're familiar with MySQL, it's basically the same syntax. But the innovative thing that we've created is this notion of a pipeline. And pipelines are a first-class object within the database. You create a pipeline the same way you create a table by saying create pipeline. You specify the data source you want it to connect to. So say a Kafka or an S3 bucket. And then MemSQL basically reaches out in parallel. Because those are parallel distributed systems, MemSQL in MemSQL's distributed system, you have all of the nodes in MemSQL reaching out to all of the nodes and the data source and pulling everything in parallel, achieving incredible performance. And because MemSQL is a database and supports transactions, we can also achieve exactly one semantics, making it much simpler for a developer not having to worry about duplicate data. And we support integration with Kafka, S3, Azure Blob, and HDFS. And one other thing about pipelines is that it's not a one-time load. It'll actually continue to pull new data as it comes in. So you can essentially set up with two statements, a create pipeline, start pipeline, an ability to continuously ingest data from any of these data sources without having to install any third-party technology. And then all the management monitoring is just built into the database. It's really a powerful feature and pretty highly used by most of our customers. And when there's more data sources coming soon. So let's talk about what NewSQL can do for data lakes. So the main big advantage is really accelerate your slow-performing queries. For people who try to use data lakes to do interactive queries, it can be pretty frustrating when the queries take minutes or hours to perform. And if you could, using something like MemSQL, get down to seconds or even sub-second queries, imagine how that would change how you work every day. Right? Being able to iterate faster to get to that business insight that's going to transform your business. The faster you can iterate, the better chance and the more insights you can get, and the more you can have an impact. And this ability to pull data continuously from HDFS or any of those data sources into MemSQL means the data is always there and fresh and available and up to date when you need it. And as I mentioned, we don't just support HDFS, we also support any of the cloud object stores. So whatever data storage technology you use, MemSQL is supported with the same abilities and performance. And it's not just about running queries. You can also operationalize ML directly in MemSQL. Because we have the full capabilities within the SQL language, and on top of that, we have the ability to construct your own business logic using store procedures and functions. you can actually do your ML operations directly in the database. So one example is we have this function called dot product we provided. There's a couple of customers we have. One of them is called Nairis, and they actually do picture matching. So you take a picture of a product, and they use the dot product to do fast vector matching to very quickly determine if that picture matches any of their known pictures in their database. And they can basically look up products in a catalog to see if that product is for sale anywhere on the internet. And they can do that within seconds, fast enough that someone could come in, show their picture, and very quickly find whether that product is available for them to purchase. And we have other scenarios where people are doing face matching or other kinds of matching technologies. And they do that all within MemSQL without any third-party technologies or anything outside the database. But let me give you an example of an actual case study of a customer who went through this journey. Excuse me. So this is actually, we don't have the name on the slide, but it's actually Kellogg was the customer. So they had a bunch of existing data sources, Oracle, SQL servers, a bunch of stuff, as well as some Twitter data. And they wanted to bring it in and combine all that data together to get answers to their business. They were using SAP data services to bring the data in. They were dumping it into Hadoop, and then trying to use a selection of NoSQL technologies, including Hive, to query the data out and then make it visible to the various people in their organization. Now, there are some people, some handful of data scientists within the organization that were familiar with Python and could access the data that way. But the majority of them wanted to use the tools that they're familiar with, things like SAP Business Objects or Tableau. And what they found is that they could get the data in pretty easily. Like that first part of the path of landing the data, they were able to do that. But they couldn't get it out in a reasonable way. The tools they had just didn't work. And when they were able to run the queries, they were simply too slow. And the quote from the executive that we worked with was basically Hadoop for them became a write-only environment. They could write it in, but they couldn't get it out. On top of that, their ETLs to get the data in was also very slow, and they were missing their SLAs to land the data in each night. That was taking more hours than they had in the night to do it. And so they needed to meet their business requirement, especially for Twitter analysis where they wanted that more in real time. And so because of all these problems, they were simply unable to meet the requirements and the SLAs they were trying to hit. And so what they did is they replaced with MemSQL. They got much higher speed query performance. All their tools just worked. They didn't have to do any sort of integration. They were able to just hook them up using the MySQL connectors that were built into SAP Objects and the dedicated MemSQL connector that we built for Tableau. Their loading of data went from hours down to a handful of minutes, dramatically reducing the time to insight in terms of the time the data needed to be loaded in to the time they could start querying it. And just overall, we're able to meet their SLAs for both ingest and query performance. So to recap, when you combine data lakes with a new SQL system like MemSQL, you can get very high-speed ingest, particularly because of the parallel loading, allowing you to achieve your requirements around timeliness and lowering latency. You can use whatever data type makes the most sense for you to land and collect all your data. You can drive low latency queries on billions or trillions of rows. And you can do that with a high level of concurrency, which is another aspect of support of things that are supported in MemSQL that you don't get in many other technologies. It's not just one person running one very difficult query, but when you have 10 or 50 or 100 or hundreds of people trying to hit the system, a lot of the, especially legacy systems, will get not be able to handle the concurrency and the load. And having a new SQL system like MemSQL allows you to scale all those requests and parallelize them without compromising query performance. And if you need more power, you can scale the system by adding more nodes. And it lets you transform and structure your data and centralize it in a way that still makes it possible to do the governance and accessibility of the data and dramatically simplifying your architecture. And last allows you to integrate it with the other enterprise systems and enterprise tooling that people are familiar with using the ANSI SQL language and standard interfaces. So that concludes my talk. My name is Rick Negrin. I work for MemSQL. I hope you enjoyed the discussion and the content, and I'm happy to take your questions.
Well, Rick,
I'll turn it back over to you.
Yeah, Rick, thank you for that excellent presentation. We'll get started with today's Q&A session, and I want to thank the audience for their participation. Had a lot of questions that have come in, so we'll do our best to get through all of them in the time remaining. And during this Q&A session, we'll leave up this screen with contact information for Rick, in case you'd like to get a hold of him following today's event. So let's get started. Rick, as you might expect, a number of these questions are relatively technical in nature. So let's talk about types of file types, particularly in semi-structured data that are supported by MemSQL. And the questions are specifically about JSON, text, Avro, and Parquet formatted files.
Sure. So as I mentioned, natively within MemSQL, you could have JSON as a column. The advantage of that is if you don't have a specific structure and you don't want to try to figure out how to schematize it, you can just dump it into a single column of JSON. And then you can actually project out properties of the JSON as columns as you identify what the common columns are, and then index them to get better performance on querying them. And so you can really kind of have the best of both worlds. And that's in terms of how you store data in the cluster. To ingest data in the cluster, we natively will pull in CSV files. Now if you have one of the other data types, you can actually write a transform to convert it to CSV. But actually, as of the latest release of MemSQL, which was released today, in fact, we now also natively ingest JSON and Avro. And in our next release, we'll natively ingest Parquet as well, making it even easier to bring that type of data into MemSQL.
Oh, well, thanks. Thanks for that clarification. Now, the audience is curious to know, does MemSQL actually have a file system built within it, and is it HDFS?
No, so the storage layer in MemSQL is built custom. It was a proprietary technology. We did that because we wanted something that could be optimized for what we were trying to achieve. So it's got its own way of storing data that supports HA. It's highly available, so we keep 2 copies of the data. It fails over automatically as needed, but it's all custom built as part of MemSQL.
Okay, well, thanks for that clarification. Number of questions around the topic of query. So the first question is, can I use Java or from Python, can I use SparkML or sklearn functions to operate directly on MemSQL?
So any technology that has a MySQL connector can connect to MySQL and run queries on the data. So if you're using Spark, we have a Spark connector that you can load up into your Spark application and use it to create and consume data frames out of MemSQL, where as they basically under the covers, we map them to tables. And if you're in Java or C++ or really any language, as long as there's a MySQL connector or ODBC or JDBC driver, which there is for all the modern languages, you can connect to MemSQL and consume the data.
Okay, and then the audience is asking how your query capability compares, for example, with other NoSQL index search tools like the Lucene index from Elasticsearch or Solr.
Sure. So Solr and Lucene are full text indexes, so they're very good at indexing large document sets, but they don't fully support the full SQL language, and their performance for things like group bys and aggregates and some of the more complicated SQL queries won't even come close. Now, MemSQL actually has an instance of Lucene engine built into MemSQL, so if you want to do full text search, we actually support Lucene within the engine. And you can mix it with our structured query search to really get the best of both worlds.
Okay, and just to expand on that, can you compare with Apache Drill?
Sure. I mean, Apache Drill and some of the other technologies were an attempt to build the query optimizers on top of the existing NoSQL systems. and the underlying technology infrastructure has made it pretty difficult for them to achieve the performance that people have been trying to get. So there are things like drill that aren't bad, but when it comes to performance, they don't compare to what MemSQL can do.
Okay. Now, in the Kellogg example that you had, did they do away with the HDFS layer completely?
Yes, I believe that. Yeah, they had a small enough cluster that for them it made sense to do just MemSQL. But we have other customers where they did it more as a complementary, where they had it be next to the HDFS layer, but they didn't get rid of HDFS, and they would pull subsets of data into HDFS. So we did a recent presentation at a conference. We talked about a company, Fanatics, who's doing real-time analysis of all the branded sports memorabilia that they sold. They replaced a number of NoSQL technologies, but kept their HDFS cluster and built MemSQL sort of into their workflow, be able to get all the same advantages that I spoke about, but without replacing their HDFS.
Okay, got it. Now, a lot of these questions are about compatibility and capability. So this one relates to MemSQL's ability to integrate with open source packages like pre-trained models in TensorFlow. Is that something that's possible?
Absolutely. So in fact, we have a demo. I forget what we did, again, at another conference where we showed how you could integrate TensorFlow into a transformation within our pipelines technology. So as you ingest data into MemSQL, it could take advantage of TensorFlow libraries to evaluate the data and create a model, and then do that on the way to ingesting the data into MemSQL.
Terrific. Thank you. Now, here's an audience question that has to do with streaming data. And the question is, does MemSQL make it particularly easy to perform the ETL function on telemetry streaming data?
Absolutely. So that's one of our biggest strengths, is being able to stream data in, transform it as you need it, and then load it into MemSQL. And like I said, we have customers who are doing that and achieving millions or even tens of millions of rows per second. And that's using that pipelines functionality that I mentioned, because it can natively bring data in from a variety of data sources. But especially if you're doing something streaming, it's commonly something like Kafka. And we take advantage of the fact that Kafka is in memory. We support both in memory and on-disk data structures. And they're both parallel, and we load in parallel from something like Kafka directly into MemSQL, achieving very high levels of performance, and still providing you the ability to do a transformation, whether it's in whatever language you want, whether it's Python or C++ or Java. You can run it in a transformation that is loaded up outside the process, or you can use a store procedure within MemSQL, whatever language technology works best for your application.
Okay. Now here's an opportunity to expand on what the implementation of MemSQL looks like. Because the question is, suppose we got MemSQL and we plan to use it on top of our data lake, and suppose we have a large amount of data coming in every day that needs to be transformed and summarized. What's the integration of MemSQL into our environment look like on a step-by-step basis? What's the work plan?
I mean, of course, it depends on the specific requirements and the details of your architecture, right? So it depends on where's the data coming from. But again, we have various different ways to support connecting to different kinds of data sources, whether they're something like Spark, or it's a messaging queue, or it's a relational database. You might use different technologies to bring the data in. And then again, we had those different options where you may want to bring the data into HDFS first, then load it in MemSQL. You may want to bring it into MemSQL first and load it in HDFS. Or probably one of the more common patterns is actually loaded into both simultaneously, the Lambda pattern. But again, you only want to do that one if you're not really doing complex transformations, because then you don't have to repeat the logic in two places. Right. Now, which way you go just kind of depends on how much you've invested in existing technologies, the sophistication and the skill level of your people, and which technologies they're most familiar with. So it's hard to give a specific answer without getting into the details of the requirements and the context of the situation.
Yeah, easy to understand. Well, here's an opportunity to talk about MemSQL in both a cloud and on-prem version. And the question is, are there different versions of MemSQL for those environments, and is the pricing significantly different?
So we actually just have one version of MemSQL, one edition, that you can run wherever you want. So you can run it on-prem or you can run it in the cloud. We made it a requirement from day one that running MemSQL in the cloud should be no different than running it on-prem, and that a number of our own internal tests actually will run it. We use some cloud, and we actually have our own data center with our own machines. And so we regularly run it in both places. So it really behaves pretty much the same. The only real difference is just what you get from the underlying hardware, right? How good your network is, how good your disks are, how good how beefy your machines are. But there's really no difference in terms of how MemSQL works.
Okay. All right. Terrific. Thank you. Now, here's a question about scalability, and it is basically, what is the largest customer data store that MemSQL currently supports?
There's really no known limits on how far we can scale it. We have customers that have hundreds of terabytes of data stored in MemSQL. We have clusters that are hundreds of nodes that make up a single cluster. We have one customer who has hundreds and very high hundreds, very soon on their way to having thousands of databases in a single cluster. So we have examples of people scaling really all different levels of, all different sort of dimensions of MemSQL. We have some that are doing, like I said, 10 or 15 million inserts per second. They do that with having a very large cluster and using mostly the row store.
Okay.
Yeah. So yeah, we scale in lots of ways.
Okay. Terrific. Thank you. When we were talking about integration capabilities, I should also have asked, the audience is interested, do you integrate with SAS? A lot of people are still using SAS.
Absolutely. In fact, we have a formal certification from SAS that MemSQL is supported. You don't even need anything specific to MemSQL. You can just use the existing MySQL connector. Works great.
Okay. And this is probably a pretty obvious question, and it is about whether or not the computations are taking place in memory or in database or on disk. And so the question is, are all of these MemSQL operations in memory? Does it hold the tables in memory or a cache, or is it operating directly in the database?
So that's a great question. And in fact, it's not quite an obvious answer because it somewhat depends. So as I mentioned, we have two different storage mechanisms. So when you create a table, you choose whether you want a row store table or a column store table. And our row store tables, the way they work, the data is stored in memory, but the snapshot and the log are stored on disk. So we periodically will snapshot what's in memory and store it on disk. And then as transactions change the data, we keep a log that's also on disk. But the changes are in memory. So when queries are run, they run directly against memory to satisfy the query, which makes our row store very fast and very consistent latency. But if the machine were to be rebooted, for example, you take the snapshot, you load it up, you replay what's in the transaction logs, since both of those things are on disk. And then you can get yourself back to where you were when the machine rebooted. So even though we have an in-memory database, you have persistence and durability and availability of the data, even in the face of machine failure. Now our column store, the data is actually all stored on disk, but we make heavy use of memory to store all the metadata. And so we can do pretty sophisticated, what we call segment elimination, where we can figure out which segments of the data we don't need to scan when you run your query based on all the metadata we keep in memory. So we're pretty memory hungry in order to do a good job of only grabbing the data off disk that we absolutely have to get to. And that's really the secret one of the secrets we use in order to get the fast performance, even on billions of rows of data or trillions of rows of data, is by being really smart about pulling into memory only the data you need to satisfy your query and hitting the disk as little as possible.
Well, thanks. That makes perfect sense, and thanks for that clarification. Here's a question that I think, I would have thought was obvious, but you should answer, and that is MemSQL available internationally?
Yeah, it's absolutely available internationally. We have several international customers. So it's just bound only by the U.S. federal export guidelines.
Right.
But anybody can access our site and download and make use of it. And in fact, as of today, we have a free offering, free tier of MemSQL where you can use it up to 128 gigabytes of memory is free. And if you want anything beyond that or you want support, then you can pay for our enterprise license.
Oh, that's very interesting. This final question is a little broader than the technical questions we've been fielding so far, and that is, can you comment on MemSQL's role in supporting or aiding data governance, control processing, and audit concerns for folks that are particularly strict about that?
Sure, no problem. Yeah, so we one of our early customers was actually in the government, and so we ended up building a number of the security features you'd find only in the most mature legacy databases. So we support various forms of authentication besides using the basic username and password. We also support SAML and Kerberos. We also support RBAC, which is role-based access control, so you can create groups and roles, put users in the groups, and then assign those groups to roles, allow you to have very granular control of the permissions and who has what access to what data. And we also support an audit feature, allowing you to understand who had access to what data. So in the event of a security breach, you can determine what data was accessed, who accessed it, and what information they saw. So we really have a pretty sophisticated set of security features that allows you to meet your compliance and regulatory requirements.
Well, Rick, thank you. Those were great answers to some very good questions. And for those of you that asked questions today that weren't answered, we'll be sending all the unanswered questions to Rick and the MemSQL team so they can follow up with you after today's webinar. I have just a few quick announcements. If you'd please mark your calendars for November 13th. That's our next DSC webinar, and that'll be Deep Learning, an Introduction to Neural Networks. Also remember that today's taping will be available for on-demand viewing later today, and you can find that on the home page of Data Science Central in the Webinar tab located at the top of the page. Well, this brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions. A special thanks to MemSQL for their sponsorship, and particularly our speaker today, Rick Negrin, for his insight into today's topic. This is Bill Voorhees. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on November 13th. Have a great day.